Hello, everyone. Welcome to this trending tech podcast brought to you by the team at IoTnow.com and TechLeadWorld.com. My name is Satyajit Sinha, Principal Analyst IoT Analytics. I've been in IT market research for more than 12 years, focusing on IT hardware, connectivity, and security. Today, we have amazing guest David. David, can you introduce yourself?
Thank you, Satya. Yes, I can. I'm David Hambling, and I head up connectivity business development in Asia Pacific for G&D. And I'm also the managing director for the connectivity hub in Hong Kong. G&D is a global security technology company, and we've been creating confidence as a reliable partner for the last 170 years. This has been from delivering the first SIM card to now continuing to innovate and pioneer in the SIM technology space. So we're here to discuss secure and scalable IoT connectivity today. So, Satya, how fast is IoT connectivity growing and what is driving it?
So if you look at IoT connections, it has reached 18.6 billion mark by end of 2024, and it is growing at a rate of 12% year on year. And the total number of connections that we expect that it will reach by 39 billion by 2030 and at the CAGR of 14%. This is very interesting because among this 18.6 billion connection, there are three key technologies basically driving these connections: Wi-Fi, Bluetooth, and cellular. So among all the three technologies, cellular is something that we are pretty much interested in. But yes, these three technologies are driving the market.
Yeah, that's massive. But where does cellular and eSIM growth fit into that picture?
Yeah, that's interesting. If you see cellular connections is growing much faster than the overall IoT connection market. It is growing at 15% CAGR. And right now it accounts 22% connections, which is 4.1 billion by end of 2024. And if you look at the eSIM adoption among these, the 32% of cellular IoT modules shipped in 2024 was eSIM or iSIM capable. And if you look at from an install base or active connection perspective, 17% of cellular IoT connection already eSIM and iSIM capable devices. And the driving adoptions are obviously smaller form factor, so security and all those things that is driving these things. But if you see overall picture, cellular connectivity is growing much faster than IoT connection market, and eSIM is also having a much faster adoption rate within that penetration.
Yeah, of course.
So, David, what are the key challenges that we are seeing in the IoT connectivity landscape that you are seeing?
Well, I think it's a little bit like what you've just said. I think it's the sheer quantity of devices out there, and that causes quite a few challenges. So I think one is the technology on offer, whether it's NB-IoT, whether it's LTE, Cat1, LTE, Cat1B. So there's so much out there. And I think it's starting to become very difficult to find a one-size-fits-all global solution for that. I mean, NB-IoT, for example, it's not available in every country. LTE-M isn't available in every country either. And then you start looking at the regulatory landscape as well. There's permanent roaming restrictions in some places. And there's also, you've got devices that are using more and more data globally, and that becomes more of a commercial issue. But at the same time, you've got lots of devices which are using very little data globally. And that also becomes a commercial issue because they're quite resource intensive on the network. So now we're seeing commercially, people are bringing in access fees in addition to different technologies. So it's almost becoming more fragmented. And from an Asia Pacific point of view, as I'm over here, you see that it's quite stark over here. It's because one country will have NB-IoT, one country doesn't. Another country is bringing in access fees for low usage devices. And you've also got the added pressure of very cheap local pricing added into that. So yeah, it's a change in commercial landscape, and one size fits all is very difficult these days.
So among these challenges, we see a solution, SGP.32. So yes. What is SGP.32 in simple terms?
Well, in simple terms, it's the new eSIM specification that is focusing on IoT. It is for IoT. And it's building on the great base of SGP.22, which was, in simple terms, for consumer devices. So SGP.32 removes the need for complicated integrations. It just makes eSIM very, very accessible for IoT devices and for the sheer range of IoT devices out there.
So interestingly, there is SGP.02, which is pure M2M. Then, as you said, SGP.22 consumer. Then why the industry need an IoT focused standard now?
So if I think back, and I think I've been in IT for quite a long time, I think I remember the SGP-02 standard being around, perhaps not in commercial use, but being around since around 2012. And from what you were talking about earlier and the growth of IoT, we're now 2025 going into 2026. With that, the IoT market has grown massively. There are so many more devices, there are new technologies, and we really needed to standardize and create a new standard for that. I think a lot of devices wanted to use SGP-32 for IoT, but there are some difficulties with that, and therefore SGP-32 was born out of that.
Interesting. And if I want to understand from a technicality perspective, that SGP-02 was pure M2M, which I knew it was based on push model, if I'm not wrong, right? And then SGP-32 came into the picture, which I think is a mix of more than push and pull model. What are the gaps that SGP-32 addresses right now, which SGP-02 didn't have before?
Yeah, so what's fascinating is once you start to understand the difficulties, especially of SGP-02, you really start to see how smart SGP-32 is. So you're right, yeah, SGP-02, it was pushing. So you would have a management portal, RSP, and you would push the profiles to the device, which was needed because these are headless devices, they don't have an interface. SGP-22 was around activation codes, QR codes, very clever, very fast, but you're not able to scan the QR code most of the time on quite simple IoT devices. So I think where then SGP-32 comes in is removing that barrier. It's allowing for mass deployment of profiles to devices, and also it's using the SGP-22 technology through the SMDP Plus to make the connectivity agnostic. So it's not, SGP-02 was heavily reliant on integrations with operators' SMDPs. And now this follows the same logic as SGP-22. So you don't have to have the integration, you're contacting the SMDP Plus of the operator, you're downloading any connectivity profile from them, you don't need to have that integration.
Okay.
But what's very interesting, SGP-02 was quite difficult, especially for some simple devices and also devices like NB-IoT devices, because some of them are battery operated, some of them are quite lightweight, and there was a necessity to make SGP-32 more accessible to devices that speak perhaps more lightweight communication protocols. So SGP-02 also used SMS as well as a more clunky communication protocol, which is great for big devices, not battery powered, that can take a long download time of the profile, and they move that into some kind of language translation and just brought out the accessibility to all IoT devices.
Interesting. And as you mentioned very clearly that as SGP-02 required that SMDP and SMSR servers, and now we are moving to SMDP plus servers. It is interesting, but now we have LPA and EIM coming into the picture and want to understand how it sits with SMDP plus architecture.
Yeah, so I think it's still on the theme of accessibility. So all of these parts work in harmony to promote accessibility to all IoT devices. So you've got the SMDP Plus, which comes from the SGP-22 landscape. And then underneath that, you've got the EIM. And what's massively interesting about the EIM is that what we needed to do when it came to making SGP-32 accessible to as many devices as possible was that we had to put the layer in the middle, because we don't know exactly what's going to be on the devices. So when you think about a mobile phone and SGP-22, what would be the EIM layer was within the device and on the mobile phone. There's a lot of mobile phone models out there, but there's a very small number compared to the massive number of IoT devices out there. So you can't rely on the fact that the devices are going to be able to do this management layer themselves. And so you need to centralize it. And we've centralized it in the EIM. And then you need to do what the LPA did in SGP-22, which is the IPA-E and IPA-D. And also in the vein of accessibility, we also know that not all devices are going to be able to build in the IPA-D. Some devices won't really need to use remote management very much, and it's going to be more insurance. So what we do there is we put the IPA on the EUICC, on the SIM. And as I said, they all work together in harmony to make it more accessible. You've got the IPA-D at the device level, the EIM in the middle. EIM also does the language translation, as it were, to be able to get the profile from the SMDP Plus, bring it down to the EIM, translate it, and then put it down to the device.
Interesting. And yes, I mean, SGP-32 was in the process of specification. And as an analyst, we see in the market, there were a lot of pre-standard coming into the picture from many of the operators, eSIM management players. But what interesting that something that came earlier this year, news from you guys. It would be great if you can share that news, what happened in the SGP-32.
Yes, we were the first company to get the EU ICC security assurance scheme compliance from the GSMA and also generally the eSIM compliance. And then after that, the first commercial deployment with Aero. So we're very proud of being able to get to that stage. I think it was 2 months after the specification was released. So we worked very hard to get there and managed to move quite fast with that.
Interesting.
How important is security in IoT today, Satya, and what are the key challenges?
I mean, security has been a very important piece of technology for any new technology that we see in the market. And even with the IoT, we are saying 18 billion devices being active. There is always a concern of data security, hardware security, network security, and the cloud security because these data are going somewhere. So there's a different layer of security that's required to protect the IoT ecosystem. And we have seen multiple challenges. We have seen a lot of ransomware attack. We have seen malware attack because most of the IoT devices are either not secure through hardware, generally traditionally secured through a software mechanism. And there is no anchor of security within these hardwares, and they are relying on the old technology of security. So there is a huge challenge that we are seeing in the market. And obviously, there are multiple solutions that is coming into the picture, hardware secure element, PUF technology is coming into the picture, creating hardware root of trust. And that is making the securities much better than what we had before. And going forward, we will have PQC, post-quantum security as well in the picture. But right now, we are in a stage where security is still considered as a cost. Hence, it makes sense to attach security to an element. You have connectivity element as well, and then security as well. And then eSIMs comes to the picture, where it brings both the aspect of it. So it's not an additional cost for the OEM to implement. It is basically a go-to factor that you should implement. And I'm sure you have seen these implementation, but it will be interesting to understand from you, how do eSIM and SGP-32 enable strong security for IoT?
Yeah, so definitely security is a necessity in today's world, isn't it? And constant threats, you need to make things as secure as possible. So, what's been great about SGP-32 is that the specification was designed and built with security as a priority. So the various different parts of the specification from the GSMA focusing on the security. Also, I think when you look at just how the technology works, I think the fact that there's fewer integrations needed with external parties, that makes it by design more secure, and the level of encryption that's needed within the SGP-32 environment. I think from our point of view, it's using our secure OS and being able to continue that use from the other previous specifications and continue using that in SGP-32. And just even from a physical point of view, I think these days we're moving in the direction of embedded SIMs with the eSIM and iSIM. And that's just for a physical security layer. They can't be removed. So you need this SGP-32 technology in order to be able to manage these devices over their lifespan, whether it's 10, 15 years, and you need the security that comes in there. And I think SGP-32, it does a lot for reliability and also being able to secure your coverage with different profiles. And that's needed as well from a device point of view to be able to download OTA updates when the security threats change, new software onto the devices. And you need secure, stable connectivity to be able to do that. And SGP-32 promotes that.
Interesting. But beyond this security, what are the top benefits that we see in SGP-32 implementations?
So I think we discussed it a little bit before. I think one of the main benefits I see is the lack of integration needed to be able to use different MNOs and connectivity partners, connectivity. You don't need to be connecting to everybody's RSP. Like SGP-22, you can contact the SMTP Plus and download the profile from there. So it's scalability as well and accessibility, being able to put this out to all the devices out there. I mean, for my job just in Asia, the amount of devices that I see, the types of devices, and knowing that SGP-32 can reach all of those. And some of these have always been out of reach to do updates remotely. And just knowing that we can actually do that is very exciting. So scalability and then accessibility is catering for all types of devices and communication protocols. So Satya, as an analyst, which applications do you expect to benefit first from SGP32?
I mean, IoT was the default, right? So IoT was the first application we are seeing that is getting a lot of traction. I mean, when IoT, agriculture, transportations, and logistics, one where you need mobility, was the first wave of adoption that we see. But apart from IoT, the interesting aspect was the automotive coming into the picture, not just from a telematics perspective, but from the infotainment perspective. We started to see that automotive getting a lot of traction for these technologies, and specifically in infotainment. And we expect also that going forward, that apart from IoT use cases, that general IoT use cases, low bandwidth IoT use cases, we will see a lot of adoption in automotive as well. Three categories for eSIM will be the consumer, IoT, and automotive going forward.
Yeah, definitely. I think especially for automotive, it always kind of bridged the gap, didn't it, between SGP-02 and SGP-22. There was a consumer aspect, there's a machine aspect, and SGP-32 bridges that beautifully. It really feels like automotive will benefit from this new specification. And from the eCall point of view, that reliability for eCall and the priority involved there.
Okay, makes sense. David, just now to understand that how GND is playing a key role with SGP32. So from a solution perspective, I wanted to understand.
Yes, well, we worked closely with the GSMA to create the specification. And then since then, we've been, I think, leading the way with POCs. We've had a lot of POCs going out there. So we're really building the landscape and preparing the landscape for mass SGP32 adoption. So I think a lot of OEMs, a lot of MNOs, device manufacturers, and IoT players, I think they're chomping at the bit to move forward with SGP32. I think it answers a lot of the challenges that they've had in the past. So I think the POCs are being really exciting because you see how eager people are to get this technology out in the field. So with that, just helping the device manufacturers build this technology into their devices, with its IPAD, for example, is getting people ready for mass deployment. And we've also had some commercial use cases already, notably Amazon Aero. So yeah, leading the way with that to push SGP32 out to the world and get people remotely controlling their connectivity as soon as possible.
Interesting. I mean, just a few days ago, I was creating this tech stack for eSIM tech stack and trying to allocate the OEMs with their eSIM features. And I saw that GND is coming in all of the steps of that tech stack. And that's very interesting. I want to understand from you what an end-to-end stack does mean for you and what it brings the benefit and what it means for the GND overall solution.
I think for our customers, the full stack means that they can use a reliable IoT partner for all parts of the IoT ecosystem. So from GND's point of view, obviously we've got the SIM card side, the EUICC side, up to the ISP, the device management. I mean, I work in the connectivity side. And what's really interesting for me is that we've got our library of connectivity profiles that can be used as well. So we can be supplying the SMDP+, we can be supplying the EIM, we can also supply the connectivity. And it could just be to fill in the gaps for people. I mean, they could use their own connectivity worldwide. And then where we might have something, say in Brazil, they don't have and they need to access quickly, and we can just download, we can give them our profile for that. So yeah, the full stack is really interesting. I think bringing all of these elements together within a very secure environment as we concentrate on security, we focus on security, bringing all of that together, wrapping it up in security, and then having one point of contact and one SLA, for example. So somebody can come to us and they can get as much as they want or as little as they want. And that's it's a very powerful position in the market.
Interesting.
So, Satya, where do you think the eSIM market is heading over the next 24 months?
I mean, that's an interesting question. I mean, what we have observed that at the very early stage, eSIM got a good traction when it came to the market and had a good start. However, we started to see a plateau and everybody was waiting for SGP32, and that was the plateau came into the picture. And the interesting part was, even before the SGP32 specification was finalized, the industry was interested in SGP32, which led to a lot of OEMs and eSIM players to keep coming up with the pre-standards. And with these pre-standards, they have already started doing pilots to try doing some of the deployments. That shows a very clear picture of the demand and how industry was eagerly waiting for an IoT specific standard. And now when we have this standard, we start to see a good growth again. So there are a lot of eSIM capable cellular modules are out there already shipping. they have both physical SIM and eSIM capable modules, but they are not in the implementation. So now what we will see quickly, that with SGP32, some of the implementation will come into the picture. We will also see some of the new deployments that will happen based on SGP32. We're starting to see slowly the penetration, that is, we're just saying 32% in the shipment will quickly go to 45% and to 50% and 60% range within next 5 years or so, the moment we start to see deployment. And these deployments will include IoT and automotive, both the aspect. So I would say, yes, there is a huge potential, and industry will basically be waiting for this technology, and now this technology is here. I expect a good adoption of SGP32 and eSIM technology within IoT and auto.
Yeah, definitely. And apart from SGP32, what other drivers do you think will push eSIM adoption?
I mean, we talked about security and everything, but I think one of the interesting things we didn't talk about that much is the in-factory provisioning. I think that is something that is coming up as equal to, I would say, important to SGP32. And it's a complementary technology, basically, but makes the use of SGP32 or eSIM much better. I mean, and for the hardware perspective, from an out-of-box connectivity perspective, it does make more sense. But definitely like to understand from you something, if you want to add anything on the in-factory provisioning, because I feel that is one of the key technologies that will change the market from a different perspective for the eSIM aspect.
Yeah, definitely. So we are looking forward to SGP42. We've currently got the pre-standard IFPP out there at the moment and in use and very, very popular. So yes, SGP42, yes, we've already got the pre-standard out at the moment for the IFPP, the in-factory provisioning, and it's working in harmony with SGP32. What I really like about SGP42 is that for devices that you don't want to be reliant upon remote provisioning, you don't want to be reducing their battery power, perhaps the more lightweight devices, this is provisioning, pre-provisioning the connectivity in the factory from a profile library, putting that connectivity onto the device so it's ready to go from day one. So this is born connected. And that's crucial for iSIM and eSIM. And then once that's been in, once the connectivity has been provisioned into the device, then it can continue to be managed by SGP32 moving forward. Then also, what's very exciting, obviously, as we continue to innovate, and we don't just, after the SGP32 successes and specifications, we continue to innovate. And then, of course, you've got the further versions of SGP32 to look forward to. So version 2, where there'll be multiple enabled profiles, which will be hugely important for automotive as well, and for reliability of connectivity and for IoT devices. And then device-initiated profile switching. And that all leads into iSIM, which is what we need to look out for as well. That's going to become more popular because of SGP32, SGP42, and then, of course, SGP42 from the factory.
Interesting. Yeah, that makes complete sense. Before concluding, I would like to understand from you, what should operator and OEM watch next and why?
I think it's what we said, version 2 of SGP32. So drawing on what we've got at the moment.
Yeah.
And I think mainly, as we said, for automotive, the multiple enabled profiles would be hugely important, especially for things like eCall, infotainment, be able to switch profiles based on algorithms, based on intelligence, basically. What's got better signal? Obviously, you need eCall to have the best signal possible, and you need to have the highest priority. So that's going to be very important for OEMs, auto manufacturers. iSIM, building it in, so this is even more secure because it's really integrated into the device. And then you need the SGP32 to be able to manage that remotely for however long it's going to be in the field. And the SGP32 needs to work seamlessly for that. And then, as I said, the SGP42 in-factory provisioning. Need to keep an eye on that when that specification is released. As I said, it's pre-standard at the moment. It's in use. It's working very well. But looking forward to that going from strength to strength.
Interesting. Thanks, David. It was really interesting and insightful discussion. And I hope you all enjoyed from the discussion.
Thank you very much, Satya. I really enjoyed speaking to you.
Thank you.